The whole point of this unit is to understand the conservation of energy. In order to understand that, we must first understand what the total energy in a system is. So the learning objective here is I can calculate the total energy of a closed system using initial conditions and algebraic expressions. So we're going to try to figure out what the total energy is, meaning if we added up all the different sources of energy, which we'll talk about next, in a system, and we also need to understand what closed means, we'll get there, using initial conditions and algebraic expressions. That's the idea of the learning objective. So first, let's talk about the sources of energy. We have kinetic, rotational kinetic, gravitational, elastic, also called spring energy, as well as other types. Now these ones, the reason these sources of energy are in blue and red are because the blue ones are typically called mechanical energy. And other sources of energy that are not mechanical are nuclear, thermal, chemical, electrical, and other non-mechanical energies. This isn't an exhaustive list. This is not every single possible source of energy. However, this is most energy that you're ever going to deal with in your day-to-day situation. And before we move on, we must understand what a closed system is. So we understand what a system is. A system is a region of space in which we care about for understanding a certain physics phenomena. But a closed system is one in which no energy transfers in or out of the system, as well as no masses go in or out of the system. So the total amount of mass, the total amount of objects you have at the beginning, and the ending amount of objects, or ending amount of mass, more importantly, should remain the same. And the total energy in that system should remain the same because we're defining that no energy can go in or out of the system. If you don't have a closed system, then what we're going to, this idea of conservation of energy, wouldn't necessarily be applicable because you're allowing energy to leave your system. Or it's still applicable if you just account for the energy lost from your system. The idea is we're going to figure out what the total energy of a system is and be able to write it algebraically, be able to write it with expressions. And that's going to help us because eventually, when we have expressions, we can do calculations and determine certain values. So that's for a future lesson. Right now, we're just trying to identify all the different sources of energy and write them all into one equation. We write this as sigma E. The capital sigma is, of course, the sum of all, and E for energy. So it's basically just saying the total energy is the sum of all energy. So you take all the different sources of energy and you add them up. Whatever energy is relevant, whatever energy you can identify the system's going to have, you put it in there. In general, we can break this down to all the sources of mechanical energy plus all the non-mechanical energy sources. Mechanical energy is going to be what we use most often in physics class because it's easy to transfer them back and forth to each other. In the previous lesson, we saw that gravitational potential energy could become kinetic energy, and kinetic can become gravitational potential energy. It's hard, however, to convert thermal into kinetic energy. Not impossible, you can convert some, but it's not very efficient. Let's take a look at an example. So you got a box sliding on a rough surface. We're going to identify all the different sources of energy this could have. So a box sliding on a rough surface, so it's going to have kinetic energy because it is moving, and its gravitational potential energy is probably going to be 0 because we're just going to declare this to be h equals 0. Our starting height is 0 meters, and so it makes sense to put that it starts with 0 gravitational potential energy. Besides kinetic energy, this object is also going to have thermal energy from the frictional force. Friction causes things to heat up. You can observe this if you just take your two hands, rub them together, and you'll feel that they are warmer, at least on the surface. Friction can cause thermal energy. Assuming that this box has already been sliding, so this is at a time where it's already been sliding, we have some thermal energy due to the friction. And that is the total energy of that system. The skill is going to be to identify all the relevant sources of energy and assume all others are 0. Just like we did here, where we assumed gravitational potential energy is 0. And this US here is standing for spring energy. Well, we don't have any springs, so of course, spring energy is going to be 0. Now, if we did have a spring attached to this, if this object was attached to a spring and the spring was allowed to be compressed, then maybe not at the beginning, but maybe later when it compresses the spring, it's going to have a certain amount of potential energy due to the spring. So identify all the different sources of energy and write them all into one equation.